Dear students, in this session we will discuss about synchronous dynamic random access memory. Dynamic RAMs whose operation is synchronized with a clock signal, such memories are known as synchronous DRAM. So as we know, there are two types of transmission, synchronous and asynchronous transmission. In synchronous transmissions are synchronized by an external clock, while asynchronous transmissions are synchronized by the special signals along the transmission medium. For example, master ready and slave ready signal, what we discussed in the asynchronous bus topic. So those are asynchronous transmission. So there externally there is no need of a system clock in asynchronous transmission. So the synchronous DRAMs, it uses clock signal for the synchronization between the sending and receiving devices. The cell array is the same as in asynchronous DRAMs. So the memory cell arrangement is same as asynchronous DRAMs. SDRAMs have a built-in refresh circuitry with a refresh counter to provide the addresses of the rows to be selected for refreshing. So in SDRAM, the special circuitry is there for refreshing. So for every 64 milliseconds, the selected rows will be refreshed. As a result, the dynamic nature of these memory chips is almost invisible to the user. So these refreshing feature or these refreshing activities will not be visible to the user. So that will be done by using this refresh circuitry for every 64 millisecond. So the selected rows will be refreshed. So this is the diagram which shows synchronous DRAMs, and we have many components in this synchronous DRAMs. So in that we have row address latch and column address latch, which are connected to row decoder and column decoder respectively, and the row decoder which decodes the row address, and based on those row address the memory cells will be fetched to retrieve the data. And these memory cells are connected to read or write circuits and latches, and this circuit is connected to data input register and data output register, and these two are connected to the output data lines. So here, if it is an input operation, the data from the read or write circuit, the sensed data from the memory cells, those will be transferred to the data output register, and from there it will go to the data output lines. Okay, from there the data will be transferred to the processor. But if it is a write operation, then the data lines transfers the data into the data input register, and input register forward these data to the read or write circuit, and here these read or sense or write circuits initiates the write operation, and those selected rows values will be updated based on the data. So here the address bits are divided into two groups. One is row address and another is column address, and we have another circuit that is mode register and timing control. So this synchronous DRAM, it works on a different mode of operation, it transfers the data in terms of blocks. So block operation is there in this synchronous DRAM, and these are the 5 lines which are connected to this circuit. So here we have a clock line which carries a clock signal, and row address stop and column address stop line which carries row address stop and column address stop signal respectively. Then we have a read or write line which indicates whether it is a read or write operation. If it is a read operation, it selects the data output register. If it is a write operation, it selects the data input register. Then we have a chip select line which carries chip select signal to select the particular chip from where the processor wants to fetch the data. So these are nothing but synchronous DRAM. SDRAMs have several different modes of operation which can be selected by writing control information into a mode register. For example, in burst operation of different lengths can be specified. It is not necessary to provide externally generated pulses on the column address drop line to select successive column, because it is a synchronous DRAM. So the clock signal is going to decide when to send the data, when to stop sending the data, and the entire synchronization, the data transfer synchronization is controlled by this clock signal. So the necessary control signals are generated internally using the column counter and the clock signal. New data are placed on the data lines at the rising edge of each clock pulse. So only in the positive clock cycle the data will be placed in the data bus. So this slide shows the timing diagram for typical burst read of length 4. Burst means a block of data. Okay, so here there are 4 blocks of data wants to be fetched by the processor from the memory, that is D0, D1, D2 and D3. So how the read operation happens in this particular diagram, by using this timing diagram we'll explain. So here we have different signals. That is, first one you can see this is the clock signal. So here you can see it has, this is one clock cycle. One clock cycle will have both one positive cycle and one negative cycle, and this particular end we call it as a rising edge, and this is a falling edge. Okay, so in the first clock cycle the row address will be placed on the address bus in the first rising edge of the first clock cycle, and it takes 2 clock cycle to read this row address by the memory unit. Actually it takes 5 to 6 clock cycle. To make this diagram simple, we have taken only 2 clock cycles. So after these 2 clock cycle, then column address is placed on the address bus, and it takes 1 clock cycle to read this column address by the memory cell. Memories means the memory unit, and it reads based on the row selected. It fetches these 4 blocks of data, and it will be placed on the data line. So next 3 sets of data, that will be the next set of data will be automatically selected by the column address drop, and it takes another 3 clock cycle, 2 for row address read and 1 for column address read. So it takes 3 clock cycle. After 3 clock cycle, it will again places another set of data on the data line. So this is the timing diagram for typical burst read of length 4 means 4 data block by using synchronous DRAM. So here the row address is latched under control of the row address drop signal. The memory typically takes 2 or 3 clock cycles. We use 2 in the figure for simplicity. To activate the selected row, then the column address is latched under control of the column address drop signal. After delay of 1 clock cycle, the first set of data bits is placed on the data lines. The SDRAM automatically increments the column address to access the next 3 sets of bits in the selected row, which are placed on the data lines in the next 3 clock cycles. And these two are the very 2 important measures used in the memory operation, that is memory latency and memory bandwidth. Memory latency is the time it takes to transfer a word of data to or from the memory. Memory bandwidth is the number of bits or bytes that can be transferred in 1 second. So these two measures are used to measure the performance of the memory operation. So memory latency gives the time gap which takes to transfer a word of data either to memory or from the memory. Memory bandwidth will give you how much bits are transferred in 1 second. So how many bits per second. So it gives the total number of bits transferred in 1 second. There are two types of SDRAMs, namely one is standard SDRAM and double data rate SDRAM. In standard SDRAM, all actions are performed on rising edge of the clock signal, means positive side of the clock cycle. In double data rate SDRAM, it accesses the cell array in same way but transfers data on both edges of the clock signal. That means in the positive edge as well as the negative cycle, or you can say that both the edges, means in the rising edge as well as in the falling edge. So double data rate SDRAM, so DDR SDRAM, it is another version of SDRAM. The key idea is to take advantage of the fact that a large number of bits are accessed at the same time inside the chip when a row address is applied. To make the best use of the available clock speed, data are transferred externally on both the rising and falling edge of the clock. For this reason, the memories that use this technique are called double data rate, because compared to standard SDRAM, two data blocks are transferred in one clock cycle. So that's why the name double data rate SDRAM. So in this diagram you can see this is the clock cycle. Here we are considering 3 clock cycle, means each clock cycle will be having one positive and one negative side, means this is rising edge and this is falling edge. So in a standard SDRAM, what happens, only in the positive side or in the rising edge the data blocks are transferred, but in DDR, in double data rate SDRAM, you can see one data block in the positive side or rising edge of the clock cycle and another data block in the falling edge of the data cycle. So here it is double. So in standard SDRAM, in this 3 clock cycle we can transfer only 3 data block, but if you see in DDR we can transfer 6 data blocks. Okay, so it is twice of the standard SDRAM. So that's why the name double data rate SDRAM. So this is all about synchronous dynamic RAM memory. Thank you.